In question number 6, two opposite quadrants of circle of radius r are uniformly charged with charge plus q the side and minus q on other side respectively as shown in figure. The electric field at the center of the circle is. We must be remembering the total field contribution by a quarter of the circle, that happens to be how much it is, lambda divided by 4 pi epsilon r I plus j, that is for the quarter of the circle. We'll be using this answer in this question now. So what I would say, first I need to find out the value of lambda. Lambda to be taken as q divided by this length will be pi by 2 into r. This is the value of lambda. So the electric field at this point will be contributed by this plus along the direction minus. So effectively I would say total electric field is lambda divided by 2 pi epsilon naught into r. How much it is 2? Simply because I just multiplied this portion by 2 because of the contribution from these two plus and minus charges into I plus j. That will be my answer here. So E is lambda to be taken as 2q divided by pi r. This is 2 pi epsilon naught r I plus j, or E is equal to q divided by pi square epsilon naught r square I plus j. Just see the options if we have got the answer there. That means option 4, that is the matching answer for question number 6. Now let's proceed to question number 7. In question number 7, three charges Q0 here and plus 5 microcoulomb and plus 5 microcoulomb are placed at the vertices of an isosceles right angle triangle as shown in figure. If the net electrostatic potential energy is 0, then Q0 is equal to, we need to find out the value of Q0. Simply write down the potential energy for this configuration. For these two portions, what I would say, it will be Q square, that is 25 into 10 power minus 12 divided by r distance would be root 2L plus the potential energy of these two configuration, it is Q0 into 5 into 10 power minus 6 into k here, distance being L, and we have got two different combination, that means 2 here. It must come out to be 0. Just k will cancel out, L will cancel out. Here we are remain with 25 into 10 power minus 12 divided by root 2 plus 5 Q0 into 10 power minus 6 is equal to 0. What I will say here is 5, it will be 5 microcoulomb numerator part, and denominator it is 2 root 2 with a negative sign. This will be the value of Q0. So just see the options which one is matching here. Option 4, that is the correct answer. Now we shall proceed to question number 8. In question number 8, a charged parallel plate capacitor has a certain potential difference between its plates. Now a 3 mm thick dielectric slab of dielectric constant 5 is introduced between the plates. Find the increase in the distance between the plates required in order to maintain the same potential. Let's have a bit of elaboration here. Initially, if this being the capacitor having the charge Q says that its potential difference was V, I would say V to be equal to Q0 A epsilon naught D. This will be the potential difference. And if it's been shifted by distance x now, and additionally dielectric slab of how much 3 mm thickness is being introduced, so this distance without a dielectric, it will now become D plus x minus 3 mm. Fine. And this distance being how much? 3 mm. So the potential difference now it is, here charge still being same, Q0, it will be, this is the field strength, and this distance, how much exactly this one is for? It is D plus x minus 3 mm. This is the potential difference up to here. And for this one, I would say Q0 is the charge, A epsilon naught. Field would be decreased by a factor of how much? Dielectric constant is being given to be 5, and this is 3 mm. This will remain same as Q naught D by A epsilon naught. A epsilon naught will cancel out, Q naught will cancel out. We are having here D plus X minus 3 mm plus 3 mm divided by 5. 3 mm divided by 5 is equal to D. D will cancel out, or I would say X is equal to 3 minus 3 by 5 in mm. How much it is? 12 by 5 mm or 2.4 mm. That's the answer for question number 8. Option 3 is the correct answer. Now let's proceed to question number 9. Question number 9. A carbon resistor has the color band sequence of green, black, violet and gold. The value of resistances. You must be remembering the color coding of the resistances. It happens to be black, brown, red, orange, yellow, green, blue, violet and furthermore. Important thing here is for last color to be gold, the variation, or you may say the tolerance level, would be plus minus 5%. And by taking these 3 color segments, we will be able to find out the resistance or major resistance part. Green, it is 0, 1, 2, 3, 4, 5. I would say 5. Black to be 0 into 10 to the power. Violet to be 7 here. This is the resistance and it will have a tolerance of plus minus 5%. So simply it is 500 mega ohm plus minus 5%. Which one is the correct matching? Well, option 2 is the answer for question number 9. Now we shall take on to question number 10 here. In question number 10, two wires W1 and W2 are joined together at point P, which is midway between the two bridges. When a standing wave is set up in the composite wire, the joint is found to be a node. The ratio of number of antinodes formed in W1 to W2 is 3. If the wires have the same radius, then the ratio of densities ρ1 of W1 to ρ2 of W2 is. We need to find the value of the ratio of the densities there. What we know here, if this is the wire oscillating in nth harmonics, then there will be n different antinodes in between. So simply the ratio of antinodes here to here, that's been given to be 3. So simply I would say, let it is vibrating in n1 mode, so it is n1 divided by 2l square root of velocity to be equal to, it is t divided by ρ1, and here in other side it is n2 divided by 2l tensor t velocity to be equal to divided by ρ2. This would cancel out. It's been given n1 by n2 is equal to 3, so it is 3 root under t by ρ1 is equal to root under t by ρ2, or 9 divided by ρ1 is equal to 1 by ρ2. So ρ1 by ρ2 is equal to 9. That's the answer for question number 10. Option 1 is the correct answer. Now let's proceed to question number 11.